Hello, friends. Welcome back again. Till now, in our different sessions on 3D printing for exotic structures, we came across the use of 3D printing, the standard protocol, different 3D printing processes, some in house development for innovative products. Now, in this session, I will be discussing about the opportunities that we see after NEP 2020, specifically in the area of the interdisciplinary research, where the 3D printing and the allied fields are having hand holding of each other, and they are useful for development of really novel and innovative products. So to start with, I am discussing the collaboration of mechanical and veterinary science. So this is the case study that I just want to share with you. One of the work that has been done in our lab. Uh, Basically, the problem is like there is a bone of a dog which is damaged, and I have to insert a intermedullary pin into it. This is a standard protocol. Like if there is a young age dog puppies, maybe a few months, then falling from a height, this type of problem occur, right? So I have to insert a pin. So after few days, in some cases it is as low as 10 to 14 days, this bone part is healed, and then we remove this pin, right? And the puppy is ready for its routine activities. Now the problem is, if I insert this pin into this intermedullary cavity, because inside it is like just like a sponge. uh, Once the dog is really excited to see his owner, basically there is a process, or you can see the way of expressing the emotions by a dog, that it start galloping. So once there is a action like galloping, there are chances that this pin may come to this end, right? Like it is added from the proximal end and it goes to the distal end, then it may pierce on the other side, because this is a metal piece, right? So we have to immediately remove the pin, and sudden surgical intervention have to be followed at that time. So the problem that has been posted to us by our collaborator, can we increase the retention of this pin into this cavity? So that is the idea of making this innovative part using this 3D printing for this type of the pin. So our collaborator, he was interested, which is basically a veterinary surgeon, to have an innovative design of this type of the intermedullary pin. So we did a lot of research survey on this, and we tried to go for the standard methodology, like by selecting a subject. Of course, the patient data is available, CAD modeling of the pin, preparing it with a polymer, and then pin selection profile through the surgeon, then making it on a metal printer by playing with some parameters like laser power, scanning speed, layer thickness, then printing on the DMLS, which is basically a metal printing, a powder bed fusion. This the full form is direct metal laser sintering. Then optimizing the process parameters based upon the output in form of hardness, surface roughness, dimensional deviation. So this is the actual part you can see over here. Now I have to insert the pin in this side, and it has to be rested at this location. Now one of the important consideration is here inside in this range, the dia is sometime reduced to the 70% than the at the entrance or at the exit, right? So we prepared different specimen of the pin. Like the idea is to have a threaded zone at the end, which will be resting over here, and then at the top, and then on this side, this can be pushed in or pushed out using an allen key type arrangement. So now by making different type of design, putting a front corner over here like a flute in a drill. So we prepared some different specimens on a polymer printer, the status printer that is having in our lab. We printed these pins, and we try to convince our collaborator, which is a surgeon, okay, this pin is a better solution which will be having a more retention. right? And then we also optimize the thread profile. Like we all understand, if I need to have something like a jamming action, right? So v profile is considered better. If we need a load bearing structure, then square profiles are considered better. So in this case we need a assembly, so we took a shape profile, right? So this is the actual dimension that was finalized. So v thread were selected, and of course their pitch, their diameter, etc., that was selected. So because this section was of the v profile, and this was using the square thread, so the total length 150 was selected for this case. Then we fabricated this specimen on the metal printer. So the standard procedure: selection of material, sieving, preheating, making a CAD file, then converting into the STL file, adding sport, slicing, processing the process parameter, importing the file into the setup. We have this DMP is the name of the model 200. Then loading the part over the machine, then inserting actual 3D printing. Then we have to remove the plate after the printing, then going for the vacuum cleaning, post heat treatment, removal of the support structure. This is by EDM wire cut, and then finally the finishing process. So all these steps have been shown graphically over here. So here this is a rush based sieve shaker, then furnace, then this is putting on the STL file on the interface, right? Then this is the 3D printer, then post operation, again heat treatment. This is the printed part on the base plate, checking its dimension and the surface roughness profile, checking for the surface hardness and other surface characteristics. So we played with the parameters like laser power, scanning speed, layer thickness, and try to optimize hardness, surface roughness, dimensional deviation. For dimensional deviation, this is basically the difference between the CAD data and the actual observed observation. And we try to optimize the signal to noise ratio, which is a standard ANOVA based analysis, and some parametric optimization for the parameter laser power, scanning speed, etc. has been done, and the multi-factor optimization based model was prepared with a desirability of 0.8. Now for all these cases that we have selected, we try to see their grain size number as per ASTM E112 and their porosity as per ASTM B276, and that was actually compared where I am getting a better mechanical property, where I am getting a controlled porosity. So this type of observations were made. So in this particular example, what I just want to show is, firstly, by the proof of concept using a low cost thermoplastic based polymer printing, the actual product can be prepared, or that has been actually used for the clinical trial also using a metal printer, and all parametric optimization has been done based upon the morphological analysis, right? So in my coming discussion, I will be showing you the actual application of making these type of parametric setting for developing a smart crowns in case of the veterinary patient. I hope you enjoyed this information. Keep watching. Thank you.